Hi, I'm Craig Rowland, founder of Sandfly Security. In today's video, we're going to demonstrate a hidden process binary running on your Linux box and why it's malicious. Now on Linux, if you give a period as the first character for a file name, it hides it. And what I mean is if you just use a standard directory listing command, you just won't see the file there. You have to use a special flag in order to see hidden files. This kind of keeps the clutter under control when you're browsing around a Linux file system. But a lot of malware, especially low-grade malware like cryptominers and things like that, will name their binary with a period as the first name because it makes it less obvious if people are casually looking at the system. But we have seen some advanced malware use this tactic as well, so it's not always something that you're going to find just low-grade malware using. Now the thing is, once the binary is dropped, a lot of times they'll run that binary with the hidden period as the first character, and now you're going to see the process itself running with that command name, and that's very, very suspicious and a great thing to look for to know if your system's been compromised. So first we're going to go over to the Sandfly user interface, and then we're going to jump over to the command line to show you what it looks like from there. But Sandfly is an agentless Linux endpoint detection and response product. We also monitor SSH keys, password auditing, drift detection, and more. But for today's demonstration, we scanned a Raspberry Pi, which is an embedded device. Sandfly runs perfectly fine on embedded devices, and they're frequently targeted for attacks, so it's a good idea to watch them. But on this device here, what we did is we found 2 alerts. There are actually many more, but we'll cover those in another video. But for today, we're just going to look at the 2. The first thing we did is we looked under the temp directory and we found a file that was hidden there called .xolock. If we go here, we're going to see a detailed description of what we saw. The file temp xolock was found under temp. It is a hidden Linux executable. Hidden executable file names are suspicious and not part of a normal Linux installation. That is correct. Linux is the premier open source operating system in the world, and the operative word here is open. Okay, so it's not trying to hide. So if you find a binary that's hiding, a process that's hiding, a user that's hiding, or anything else that's trying to hide on Linux, very, very high chance it's malicious and up to no good, and you should take a close look at it. This is no exception. So here we found a file. It's a binary that's hidden. I have the basic file attributes here. We also have detailed file attributes under our raw results. This gives you everything about file creation dates, inode, permissions, flags that might be set on that file that give it some special access permissions such as immutability, and of course the SHA-1 hashes and SHA-256 hashes, things like that for looking up in malware databases. But the next thing we found here is not only was this binary hidden, someone started a process, and that process is actually called .xolock because they just ran the binary directly and the process didn't rename itself. So in this case here, we found a process here, xolock, with a PID of 14721, and it has a hidden name. And this can sometimes be legitimate, sometimes, but we say that as a hedge. It's usually malicious. But this time it's done, it's often done as malware to hide. So again, same deal here. We see the process name. I see this command line here that has some suspicious flags to it. Raw result data, again, shows, process information, when we made it, who owned it, file descriptors it has open, environment information about it, as well as information such as network ports. So in this case, we see a TCP port listening on port 13337. So everything about this process says it needs to be investigated, which is what we're going to do now when we switch to the command line. So I'm over here on the terminal, and I'm in the temp directory. And if I do an LSAL, you'll see here kind of why attackers like to hide in the temp directory and kind of do this hidden directory thing. So I did an LSAL. This is going to show us all the hidden files. If you didn't run that command, this is what it would look like. You would just see kind of this junk here. You wouldn't see it. But the LSAL actually shows us all the hidden file attributes such as font Linux, ICE Linux. And we go down here and I see a couple things interesting. I see xolock and I see xolock. The difference here though is they gave this file not the letter L, but the number 1. It's probably something you didn't see initially when we showed you it, but this is a very common way to hide. Clearly, this file here is 11 bytes, but this file here is 67 bytes. What I can do, if I run the file command, let's see, x0, let's see, lock, with the 1, I can see here that's an ELF executable. It's an ARM because this is a Raspberry Pi, but I can see this is actually an executable file. I can also run SHA-1 sum on it as well if I want to, for instance, take that file and see if it's in some databases somewhere. This isn't super reliable, but you might get a hit on it. So again, here I have the file attribute. But the main thing here to understand is that this file is definitely up to no good. Now, let me clear my screen up here. A lot of Linux commands have something to help you investigate a suspicious process, and that's called LSOF, which stands for list open files. We're going to do -P with the process ID, and our process ID that we grabbed from Sandfly was 14721. So we're just going to put that down here, and I'm going to hit enter. Now at this point, we're going to see current working directory is temp. Yep, we know it. This is the full path. Yep, we know that. We can see the libraries that it has open, and we can even see down here the listening network port it has open as well. So LSOF is a great way to kind of see everything in one spot as to what's going on. If you wanted to do more of a manual investigation, you would need to go to the proc directory if you don't have LSOF loaded. So it'll be proc, and then you put the PID here, again, 14721. At this point, we're gonna do LSAL. List on here, we see some interesting attributes. Current working directory, I got the full path to the process. If I go to the file descriptors here, cdfd, I can list over here, again, the open file descriptors, including, again, that open socket. So at this point, we would want to use netstat or the IP command to list out the open sockets. But you can start to do your full process investigation. We cover that in our blog and other videos as well to kind of get you going there. But this is kind of a general overview of what we're going to see happen in terms of a hidden process binary. Like I said, 99% of the time you shouldn't see it. There might be some occasional cases where you get a process that started itself with a period as the first letter. I don't know why some programs developers feel like they want to do it. I think it's a dumb idea, but some people do it for whatever reason. But most of the time, in 99% of those cases, a hidden binary running on your system is going to be malicious. So you got to look out for it. So I'm Craig Rowland from Sandfly Security. Thanks again for watching the video. Please subscribe. Check out our other videos because we have more Linux intrusion detection, incident response topics as well. So go check them out. I appreciate your time today. Thanks a lot for watching, and goodbye.